Hello, we're Peter Amer and Cheryl Quinton from Abacus Bio. We've put together some slides on cap reproduction and we're going to talk you through them. We've got Annie O'Connell from Beef and Lamb Genetics listening on, and she's going to ask us questions as we go through. Just to give you an initial rundown, this cap reproduction thing, what's it all about? Well, it's something that we are bringing in to replace the old dual-purpose reproduction subindex. And we can see on this figure plotted here what the difference is between the two reproduction subindexes. Along the x-axis of the scale, we have rams that are increasing in their prolificacy, i.e. they have higher number of lambs born breeding values. So if we were to rank the reproduction subindex for these rams on the old linear scale, for every unit higher number of lambs born, they would get a higher index value as shown by this blue line. But with capped reproduction, from about the average number of lambs born breeding value, which is close to zero, they already start to get less and less value for every unit increase in NLB breeding value as it goes up. So you can see that once you get into breeding values above about 0.2 and especially above about 0.4, that there's quite a bit different. With capped reproduction, you get quite a lot less subindex value. And the value plateaus until it reaches a cap, and that cap is at a number of lambs born breeding value at about 0.7. And at that point, the maximum subindex you can get for cap reproduction is about 1,024 cents. So the impact starts at quite a low level of number of lambs born, but it gets bigger and bigger as the rams get more prolific. So why do we want to use this new subindex for reproduction? Well, in simple terms, the reason is that farmers don't want too many triplets. So triplet-born lambs have high death rates. Having triplets have high death rates, and triplet-born lambs are hard and slow, hard to finish. It takes a long time. So as we get more and more prolific rams, they tend to give us triplets. If we look here at this figure, we can see how the proportions of single lambing ewes drops away as scanning percentage. This scale here, lambs born per year lambing, is very similar to scanning percentage. So the proportion of ewes having singles drops away as our scanning percentage goes up. We get more and more twin-born ewes, but that reaches a peak. And that reaches a peak because we start having ewes that have triplets as the scanning percentage goes above about 150%. So if we look at what the economic value does on this scale, if we were to compare going from low number of lambs born breeding value to the SIL average, effectively we're going from this point here where we have 70% singles and 30% twins to 55% singles and 45% twins. So we've got 15% less singles and 15% more twins. So twins are good and singles are not so good. So there's a high economic value for a movement in prolificacy through this range. But if we go up into more prolificacy, instead of substituting singles for twins, we actually start to introduce triplets at a more and more increasing rate. If we take that through to an extreme where we think the optimum is, then we would have 20% singles, 55% twins, and 25% triplets. So therefore, the value of going up from the average up to here is way less, because instead of just substituting singles for twins, we're actually substituting singles for triplets. So if we look at what the economic value should be, depending on where we are on this scale here, so as we move along the scale, what's the extra value of generating more lambs? Well then, at a relatively low scanning percentage for your flock, then there's a high value of increasing the scanning percentage further. It's about $30 per extra lamb scanned per ewe. But as you increase and further your current scanning percentage, then the extra value of going a unit further is much lower. And that extra value of more prolificacy, it keeps dropping and dropping and dropping until it reaches zero. So there's at about 2.13 scanning percentage, there is no benefit at all of going any further. But the point is also is that as you approach this optimum, the value of going further is also quite low. It's much lower than it was when you were way back here at this low scanning percentage. So you can see from this graph that actually these very, very highly prolific animals should actually be penalized. They are negative on this economic weight scale. But we don't actually put any penalty on in the CAP reproduction index. So in theory we should, but there are two practical reasons why we don't. So firstly, there is still a role for very high NLB rams because most ram breeders would have some clients that are coming to them and saying they're not happy with where their current flock scanning percentage is, and they want a big lift, and they want to do that with high-powered litter-sized rams. So there does tend to be a role for some of those prolific rams. So we don't want to penalise too hard because of that. There's another reason as well, in that selecting for what we call an intermediate optimum, so selecting penalising low NLB rams and penalising very high NLB rams is a little bit pointless if you don't want to move the population anywhere and you're happy to have a little bit of a range. So what we'd be doing if we penalise the high NLB and the low NLB, we'd be using up selection pressure but not shifting the population anywhere useful. So that is inefficient. So it's the other reason why we avoid having a penalty on the very high number of lambs born rams. So effectively this CAP reproduction is a compromise that cannot be avoided. So another perspective on this issue of CAP reproduction is it's in a way a response to what we heard from many farmers and breeders that would say, why is this ram at the top of the list? He's only good for number of lambs born, he's not good for anything else, and his number of lambs born breeding value is so high that I actually don't want all his daughters that are going to be lambing triplets and not good for anything else. So with this CAP reproduction, when we look at this approach for different kinds of rams, in the table here we've got three different rams: Ram A, Ram B, Ram C. Now, if we think of Ram A, he's high for number of lambs born, but he's poor for other traits, especially carcass weight. And so his index with dual-purpose reproduction would be high because there's a strong weighting on litter size, and that would be enough to get him a high ranking. But his index with CAP reproduction would only be moderate because we wouldn't be giving him all of that credit for the high prolificacy. If we take Ram B, who's good for both traits, he's going to still rank highly on both of these indexes. And if we have a ram that is poor for number of lambs born but high for carcass weight, he will tend to rank moderately on both indexes. So the target, the kinds of rams that we're trying to target with this index is these ones that are good for number of lambs born but have low, that are poor merit for other traits. We don't want them to find them at the top of the overall list. So to try and understand what impact this might have in reality, we took a large industry analysis and we picked out of that analysis the top 100 rams. Firstly, when we looked at the conventional or the historic linear weighting reproduction subindex. That's this column here with the grey title. And then we picked out a different 100 top proven rams from that analysis This time we used maternal worth with dual-purpose capped reproduction. So we can see by using the capped reproduction what the difference is in the rams that we got. So first of all, we can see that using capped reproduction, we knocked out those really prolific rams. Well, they didn't get quite as much preference, and so they didn't make the top 100. But for growth, we actually got more growth, because by not going for those high NLB but not so good for other trait rams, by not having them in our list anymore, we get more for growth. We get better sub-index for adult weight, we get better sub-index for survival, and wool comes out at about the same. So you can see that what the index is doing, it's allowing us to get more genetic gain in other traits and knocking off those extremely high NLB rams. So what are the implications of all this? So the first comment is that this capped reproduction is not a penalty. In effect, the linear dual-purpose reproduction index was grossly overvaluing the high prolificacy rams, because all they're going to do is deliver triplets and quads when the index is assuming that those are worth the same as twins versus singles, and that's just not the case. The dual-purpose capped reproduction curve is reflecting the extra value of multiple lambs, but based on where those rams are going to take you. Are they going to take you too far beyond the optimum for your farm? So they better reflect the biology and the economics. And one thing we could have done was just say, well, let's leave it as it was, but then when the rams reach a certain level, we won't give them any more value. The problem with that is that the true economic value does actually curve over the way that we have it in the capped reproduction. So it's the extra triplets that you get as you become more and more prolific, it slowly creeps up and kind of accelerates, so that there are decreases in value the more you approach that optimum. So with the capped reproduction, high NLB rams still have a positive sub-index value. So that's because above the optimum we still give them the max capped value, so we're not penalizing them, we're just not giving them excessive credit that is not warranted. So up to the cap, animals will rank the same for reproduction. If you look at the rams ranked on their reproductive sub-index, the ranking of them doesn't change with cap reproduction until you get to the cap. And then all the animals that were above the cap, they'll all have the same index value. So you could say that there's kind of a re-ranking there. So to wrap this up, our conclusions: a non-linear then flat economic value is for number of lambs born is an efficient approach for multi-trait selection and a number of diverse populations that these indexes have to deal with across New Zealand. And what we really want to do is to mitigate the risk of overemphasizing very prolific genetics and therefore have the industry overshooting the optimum litter size. And at the same time as avoiding this overshooting, we also have an opportunity to get better responses in growth, survival, and new traits. I hope you managed to get something out of this. Now we'll take some questions from Annie.
That sounds really quite a good balanced approach, Peter. So what if I want to select for really prolific animals still? How do I do that with the capped reproduction in place?
So the best option would be to look at the number of lambs born breeding value itself. So you would have to check that if you use the maternal worth sub-index, you might find some otherwise good rams that are not as high as you'd expect because of the capped reproduction sub-index. You would do that by looking for high NLB rams that are perhaps a little bit below your cutoff threshold, that you might want to shift above the cutoff threshold because they are delivering the number of lambs born that you want. We wouldn't advise just looking at the number of lambs born breeding values by themselves, because then you run the risk of selecting the very prolific rams that aren't good for anything else.
Okay, so you'd sort of say start with the index of New Zealand maternal worth and then go to the NLB EBV after that to find those that are higher in that.
And try not to go too far down the list, because the further and further down the cap reproduction list you go to find your high NLB rams, the poorer they will be for the other traits.
Right, so it's to look at that balanced approach for still finding those high rams. And likewise, if I wanted a good ram from maternal worth, but I wanted to avoid high reproduction, I could secondarily look at that breeding value again and just remove any that have got a particularly high NLB EBV. Is that right?
Exactly right. Yes, yes.
So if I was a breeder with a pretty high prolific flock and I had rams that were up in the NLB value of 0.6, how will the dual purpose cap reproduction index affect me now?
Okay, so if we look at this plot here at about 0.6, there's an average drop of about $7.50 or 750 cents for rams at the 0.6. So what we would be saying is that your rams were previously overvalued by 750 cents on New Zealand maternal worth, so they would drop by 750 cents.
So in this example, my flock, I think is quite good in growth. The rams are really good for growth and wool and other characteristics important to maternal worth. How will they fare?
So they won't be affected. It's just that you won't get the excessive value or the overvaluing of the high prolificacy.
Okay.
So you should still have, if your flock is good for other traits, it should still rank relatively highly on maternal worth, because remember that all the other prolific flocks are going to be realigned also in this way.
Okay, excellent. So, and looking at this graph, it looks like it starts to come in at a below 0.2 NLB EBV. Where does it first kick in?
So it just slightly about zero, or very slightly above zero. There is a very small effects, but they're there, but they don't really start to become larger until, say, 0.2, and then by 0.4 there are going to be substantial re-ranking or re-ranking effects.
And so those are matching that when the triplets are starting to increase in the flock, so that's cool.
Correct, yes, that's right.
And what happens at the low end? Below zero there's nothing, is it just like the linear?
So that's right, so we've left the low end to be unaffected by this, so that below average the rams will get the same penalty for low NLB as what they would have under the old system, because they are the rams that will mean that instead of getting twins you get singles. So, and that deserves a strong penalty.
Okay. So how will we review this in the future? I mean, obviously there's just been a big change in the value of lamb and part of the way SIL recognises lamb. What will happen in the future? Will this capping be adjusted to future changes, or how will that be managed?
Yeah, so there's two types of changes that could impact on this capped reproduction thing. The sort of more routine one would be if there's a change in, say, the lamb price, would be the most likely one, in which case a review of the SIL indexes would need to take place, and all of the economic weightings would change, including cap reproduction. So there would need to be a new formula calculated to make this happen. There's another kind of change that could happen. For example, if management improves, management of triplet-bearing ewes improves, so that both ewe deaths and lamb deaths associated with triplets was to reduce, or it could possibly increase if weather got worse at lambing. If that was to change, then we would actually shift the optimum, and the point at which the optimum was calculated would change, and that would change the shape of the bend of the curve that you're looking at right now. So it's a wee bit hard to imagine that that would happen, but that is another way that that this thing could change in the future.
So it can be expected to be quite stable for now, but if those big items change, then of course it'll be looked at again, or it'll be updated.
That's right, yes.
Sounds very fair.